Okay, hello students. Today we're going to look at our fourth lesson in trigonometry, and we're going to look at the sine rule today. So the point of today's lesson is that we want you to be able to solve two-dimensional practical problems involving the trigonometry of right-angled triangles and non-right-angled triangles, including problems involving angles and the use of true bearings. So let's look at the sine rule first of all. Now it comes in two different ways. Let's have a look. If we have a capital letter, that's going to be the angle. If we have a small letter, that's the opposite side of that. So the sine rule states that the side A is over the sine of the angle A equals B divided by the sine of angle B, which is equal to side C divided by the sine of angle C. Or you can flip them around the other way because they're equivalent fractions. So it doesn't matter which way you express this equation. They both work out for you. So if you are working around angles and sides and you're getting a little bit confused, just choose one and stick with it. That will help you out. Now, the sine rule is useful for not just for all triangles, not just right-angled triangles. Note that the capital letters are the angles and the lowercase letter is the corresponding opposite side. And your check is that the biggest side should be opposite the biggest angles. So let's have a look. We've got a pole on an 8% incline, 8 degree incline towards the sun and casts a shadow 20 meters long. Now the angle of elevation to the top of the pole is 40 degrees. How high is the pole? So someone must have been driving into that pole to have it bent that way, I suspect. So what do we need to do? We need to draw up a diagram first of all. So we need to say, well, the angle of elevation to the top of the pole is 40 degrees. So we're going to draw in our angle of elevation. So we draw in our pole. And we draw in all the details first of all, and then let's work the sine rule. So the question is, how high is the top of the pole? So we are looking at this one up here, aren't we? So what do we need to say is that side A over the sine of angle A equals B over the sine of angle B. So in this case, we want to say that, well, this is B. So that must be that this is angle B. And then what do we use for that? Well, we can use the 42 degrees just to say that because we've got this measurement here. So we're going to call that A and we'll call that A there. So now we can just rearrange our equation so that B equals the size of side A, so that's 20 meters, over the sine of angle A, which is 42 meters. So remember they're opposites. And then we're just going to multiply that by the sine of angle B. So that's this one here. And that should get you 19.21 meters, which is really dang high for a pole. So that's not really realistic, to be honest. Those big tall ones on the farm, for example, are only 11 meters high. Okay, let's think about fishing. Now we've got 2 meters of line is strung off a 1.75 meter fishing rod. Now it's held at an angle of 60 degrees. So what is the angle that the line makes with the top of the rod? So what do we know? That's 60. And what do we got? A 1.75 meter, and that's about 2 meters, and we're asking for this one. So let's just draw that into a triangle and fill in the details. So that's the information that we know. So now let's work the sine rule. Now we're going to calculate an angle instead of calculating a side. So I think I've just flipped them around, the sine rules. Now that doesn't matter, because if you know how to work algebra, that will be fine for you. So what we're going to do is just substitute in and calculate that. So what do we know? We know that we have been given angle B and we've got side B. So what it was this, so that's angle B was 60 degrees, so sine 60 over 2. And what are we going to try to find? Angle A. So we want to think, oh, well, sine, that's just sine, spell it properly, Mr. Beasley. So sine something, we'll just call it the sine of A over that. Oh, we've got a little bit of a problem. We're going to have to look at C to do a little bit of a minus because we don't have that information. So we're going to have to work out this angle first. So what do we do? Instead of looking at A, we're going to have to do sine C and then get back to, and just get 180 minus those two angles to get there. So let's do it. So we don't know sine C, but we know the distance of C. So we've got 1.75 equals sine C. Now we can just manipulate that. So remember, that's a divided by 1.75. To bring it to the other side of the equation, just multiply it. So that's what I've done here. Sine 60 over those 2 meters times the meter at 75 should give you sine C, which is the sine of 757, sorry. So we just go shift sine of that, and that will get you 49.27 degrees. So that's 49.27 degrees there. Now this is a two-step problem, so we had to do that because we weren't given the value of this side here. So now we just say 180 minus that 60 minus that 49 will give you 70.73 degrees. So the line makes an angle of 70.73 degrees with the top of the rod. Oh, look at that. 32. Okay, let's look at Bob. Bob's sailing his boat and he notices a tower at a bearing of 300 degrees true. So I've put a protractor in there. So just remember, true north is always 0 degrees. East is 90 degrees. South is 180 degrees. West is 270 degrees. And a lighthouse at a bearing of 220 degrees true. So here's Bob in his boat at this point. He's sailing on a protractor, obviously. That's a fancy boat. Now, from the map, he knows that the lighthouse is 5 kilometers away from that tower. So you could use that with the scale factor, for example. And it's also on a bearing of 155 degrees true from the tower. So how far is Bob away from the tower? So we need to fill in what we know. So we can certainly fill in this. So we know our formula and we know that what is, so angle B is 80 degrees. So that's this one here. So that's 80 degrees there. And the B is 5 kilometers. Now I had to work that 80 degrees out from 300 degrees true. So I just did that as a minus. Now let's put in our sine relationship. So we know that T for tower. So I'll just call that tower up here instead of put a T, and L for lighthouse. So you can see that I've just used those letters instead of A and B or C. And so we've got T over the angle of T equals L over the angle of L, the sine of the angle of L, and so on. But I do know the value of the distance B over the angle B, and that's 5.077. 5.077, yeah. So to find the distance L, we need to find the angle L. So let's have a look at this one. So it's 220 degrees true. That's the bearing, and it's going to be minusing the other bearing of 155 degrees true, so that's 65 degrees for angle L there. So now we know two angles. We can find the second distance from that. So that's nice. If we know two angles and one distance, we can find the second distance. So L over the sine of 65 equals 5 over sine 80. So L equals 5 over sine 80 times sine 65, and that's 4.6 kilometers. So Bob is 4.6 kilometers away from the tower. Obviously this map's not quite to scale. Okay, let's have a look at Sam the surveyor. She's on one side of the river and notices 2 poles on the other side of the river. She knows there's 2 poles to be 100 meters apart. So we're looking at the first diagram here. Now pole B is due north-northeast and pole A is just northwest. Okay, how wide is the river? So Sam's down here and she's looking north-northeast. So northeast is what? 45 degrees true. North-northeast is half of that. So half of 45 is 22.5 degrees. Now northwest is a little bit trickier, isn't it? Because that's 270 for west plus another 45. So what's that, about 315? So all we need to do now is to fill in this detail first. So we've got 67 degrees, 67.5 degrees for that angle down there. And we also know the opposite side. So we know 2 of the factors so far. Let's continue. So we now need to find side A or side B. So remember, this is pole B, so that's got to be side B. And this is pole A, so that's got to be side A. So let's just find side A then, because I just chose it randomly. I could have done the other one. So it's 45 degrees. Let's see how we work that out to be 45 degrees. So if I am thinking about northeast, southwest, remember north is 0, east is 90, south is 180, and west is 270. What are we doing? We are looking in at that sort of degrees there. So there's got to be a 45 in that one and a 45 in that one. So that makes that straightforward for A. We can think about side B while we're on here. So remember, that's 0 for north, 180 for south. And if we are looking in at 22.5 degrees, which is north-northeast, that's 22.5 there. That means these 2 are vertically opposite, and this and this are vertically opposite. So that's your X rule from a long time ago. We'll have another look at that, I suppose, another day. So those 2 sorts of angles are equal. They're called vertically opposite. So that will be a vertically opposite angle, and you can work out that to be 67.5. Okay, so from there we use the sine rule. And what do we know? We know the angle S, we know the side S. We've now worked out the other 2 angles, so we're just going to choose a random side. So I just chose A at random. So let's substitute in what we know. So the A should equal the side S, which is 100, over the sine of angle S, which is the sine of 67.5, multiplying that by the sine of angle A. So that's sine 45 degrees. Plug that into your calculator. Yeah, you've got 76.54 degrees. And so what is that? That's side A. So that's this one here. So this is nearly there. What we need to think about now is the width is going to be part of the right angle. So we're looking up and down here from Sam to the other side of the river. So the width of the river forms a side opposite to angle B. It's at right angles. Okay, so just think Sokotoa. Now this is an opposite side. That's a hypotenuse. So opposite and hypotenuse, that looks like a sine relationship. So the sine of the angle equals the opposite over the hypotenuse. Therefore, the opposite equals the sine multiplied by the hypotenuse. And so that will substitute in as sine 67.5 times 76.54 meters. And that will get you 70.71 meters. So the river is 71 meters wide. Finally, there's some exercises here for you to do, so show your mastery. Okay, can you solve 2-dimensional practical problems? involving the trig of right-angled and non-right-angled triangles, including those problems involving angles and using true bearings.